Welcome, SciCommers. Today we are joined by Dr. Erin McDonald, Science Advisor for the entire Star Trek franchise, internationally sought after public speaker, educator, STEAM advocate, writer, and technical consultant who explains complex physics and astronomy ideas to varied audiences. She is a one-woman science communication career panel, and we are very excited to have her here in the SciCommers community. Erin, the floor is yours now.
Great. Thank you so much. It's a pleasure to meet and see all of you, at least your names in the chat. But yeah, I have kind of a brief kind of presentation, basically goes through a little bit about my career and then some of the advising that I've done on Star Trek. And then, yeah, there will be time for questions. So I'm going to start sharing and let me see. That should work. Let me do that. All of these fun things. Oh, right. I assume everyone can see this. Yes. Excellent. All right.
Yep.
Okay. Thank you. So yes, I work as the science advisor for the entire Star Trek franchise. I've had a weird, varied path to get here. So I'm going to kind of walk through what took me here. And then, as I said, a few of the contributions that I've made to Star Trek, which, knowing most of you kind of have a science background of some sort or another, hopefully you find entertaining, because there's some wins and some losses and challenges for science advising in the entertainment industry. So the first thing to be aware of is that we are going to spoil Star Trek for you. And so if you're not up to date with the current Star Trek series, I apologize, but there's going to be spoilers. I'm not going to be talking about the current season of Star Trek Picard because my NDA precludes me from discussing seasons as they're airing, so I'm not accidentally saying, oh yeah, you're never going to see that again or something like that. But my background is actually gravitational waves and general relativity. I did my PhD at the University of Glasgow as part of the LIGO collaboration. I was specifically focusing on gravitational waves from neutron stars. And this was pre-detection. So this was before they had actually ever discovered gravitational waves. And mine was all about theoretical sort of how best we can use the data flow to discover neutron star continuous gravitational waves. So I worked in that for a little while. I did my PhD, and then I worked as a postdoctoral researcher at Cardiff University, still with the LIGO collaboration, before I left in 2014. And of course, famously in 2015, they made their Nobel Prize winning detection, which is fine. But yeah, I moved on from academia. And a lot of it was just because when I got into research and university, I never had like a goal of becoming a professor. I just was interested in studying space for as long as I could. And so once I was kind of a postdoc, I was like, oh, I don't know if this is for me long term. So I got into science education. It's not a picture of me, but it's a picture of a friend of mine. And I worked at the Denver Museum of Nature and Science as a, quote, educator performer. I had done some acting classes while I was a postdoc because I realized I needed a hobby and hadn't talked to a non-scientist in a very long time. So I took some acting classes. And then once this job came up, it was just a part-time gig. But with my PhD in astrophysics, they just said, go to the space area and just answer questions about space for 7 hours a day. and that's what I did. I would dress up in spacesuits and go on a Mars diorama and talk to kids about what it's like to live on Mars and future time portals and all that fun stuff. But it was great. I know we'll touch on this, but just knowing this audience, I would say that this was probably the best training that I got for science communication, was working at a science museum. And volunteering as well, of course, is a good option. But just because you get every single question from every single possible background you can imagine. You go from talking to a 6-year-old who's just learned about black holes and is worried that they're going to eat them one day, to like a retired aerospace engineer who casually pays attention to space news, but has a very technical background, to talking to maybe a retiree who last took an astronomy class in the 1970s. And so that really trained me well to adjust how I answer questions, how I talk to people about space science. I couldn't pay the bills doing that. So I started working as an aerospace engineer in Colorado, helping advise the government on technical satellite systems. And I missed teaching was the main thing. I really, really missed teaching. And so I started going to sci-fi conventions and giving talks about how science and science fiction are related. Now, this could be like the physics of warp drive or the physics of, faster than light travel, time travel, multiverse theory. I talked about science in the video game series Mass Effect and Star Trek. And I did these for fun because I was a sci-fi fan and I really loved teaching. And I loved this audience in particular, who are a lot of sort of pop culture nerds who have a real interest in science, but no access to maybe going to a university and taking a class or anything like that. So I was doing those just on my own dime, my own time on the weekends, going all over the country, giving these talks at pop culture conventions. And then life and the universe brought me out to Los Angeles. I'd always wanted to live here. And I got the opportunity. I transferred my contract out to LA Air Force Base. And for me, who's always been a big fan of movies and television, that was great. I was like, I just want to be among it. I just want to be around it. I love this. At these conventions, I'd heard that people had done science advising on TV shows. And so I was like, well, the first thing I got to do is just get to LA. So I got out here and I had met so many people at these conventions that I got to actually hang out with them outside of that realm, talk about my career. Of course, being out here, people are like, oh, my buddy's writing a pilot. My friend's working on this TV show. My friend's working on this movie. And I started getting connections to all these different creatives. And one of those connections I got was actually to a writer on Star Trek. Star Trek Discovery had just started. And they asked me not to come and help them advise, but to go to their official convention and give my science talks. So these are licensed Star Trek conventions put on by CBS. And I would come and talk about the physics of warp drive, faster than light, everything that we know and love in Star Trek, physics of Star Trek, essentially. And they were really popular. I went to the official convention back when it was in Las Vegas for a couple years. And then I also got invited on the Star Trek cruise, which I just got back from my fourth one. So that's a thing. And, but again, they love science. It's a big part of Star Trek and science fiction. And so using science fiction to teach science is incredibly effective and very popular and does help you reach a much wider audience who can use that science fiction as an anchor point to then learn hard science concepts, even if it's like, this is why this doesn't work. Like, this is why lightsabers don't really work. At least you're still teaching some science in that realm. But then, so as I was doing these, then the call came in, the call all of us scientists want, that Michelle Paradise had just taken over for Star Trek Discovery for season 3. And she was wanting some scientists to come on and help get some science integrated into the storyline. Now, at this point, they had already come up with a season-long arc for Star Trek Discovery season 3. It was called The Burn. And essentially what happened was Star Trek Discovery has now flung itself into the future. They're arriving in a world where warp drive is not really a thing anymore because this incident happened that destroyed all of the active dilithium in starships and blew up a bunch of starships, destroyed the dilithium. And the culmination of this, because I warned you there would be spoilers, the cause of the burn was a child who cried out at the death of his mother, and that permeated space and blew up dilithium. And Michelle was like, please science this for us. And I was like, okay, let's do what we can. So the first thing that I had to do was really just look at dilithium, because dilithium is fictional. It's in Star Trek, but it's been around since the 1960s when they first started. And the key to remember with dilithium is that it's not the fuel for warp drive. Now, most people at least have heard of Star Trek and maybe have heard of warp drive around that. essentially what they're doing is they use a bunch of energy to build a bubble of space-time around the starship, and then that bubble of space-time pushes that ship faster than the speed of light. But dilithium isn't the fuel for the warp drive. The fuel is actually energy coming from matter and antimatter reactions, which are a thing. But dilithium acts almost like a regulator for that, to make sure that those processes don't get out of control. So I was like, okay, so first I have to establish that dilithium is not dilithium, because chemistry says no. So dilithium is just its own thing. And what makes up dilithium? Now, the big key that I had to work with for the burn is that it had to happen and propagate faster than the speed of light, but not instantaneously, because part of the plot was that they were going to kind of black box the burn to try to figure out the origin point. So I had to think like, okay, well, if it's not happening at the speed of light, because that would take thousands of years to permeate the galaxy, that takes us into the wonderful fictional realm of subspace. Now, subspace, if you have that sheet of space-time that we think about, subspace is the area above or below it where physics rules don't really matter anymore. And Star Trek has used subspace forever, especially with communications. They have what they call subspace buoys that are able to transmit communication faster than the speed of light. So I was like, okay, well, what if dilithium has a component that permeates subspace? Doesn't totally exist in subspace because we can see it right there in front of Scotty. So it has to exist in our normal space, but it can also permeate subspace. Then I went down a deep rabbit hole. I was like, okay, mathematically, one can think of subspace as the imaginary plane compared to the real plane. Again, mathematics. If people remember, complex numbers is the combination of the real numbers and the imaginary numbers. So what if subspace is an imaginary plane? And what if, when you think of our subatomic particles, what if there are complex, so both real space and subspace, gauge bosons that help make up dilithium that can permeate subspace? And then when this boy cries out, it happens faster than the speed of light. And it basically is the resonant frequency. He cries at the resonant frequency, and that shatters all of the dilithium. The great thing with this is when I went down this deep, dark rabbit hole of thinking about these like subspace, particles, and I was like, just me, Aaron Nerd Brain, was like, what if that's dark matter? What if dark matter is a thing and it just exists in subspace and it has and so we actually ended up, when they find, it's like offhand comments, this never got actually put into the story, but the planet that they find is in a dark matter heavy nebula that we did manage to call the Verubin Nebula after Vera Rubin, who discovered dark matter. So we threaded it all together eventually. But yeah, so that was kind of the yes-anding process of my first gig on Star Trek, which I'm still very, very, very proud of. And then I'm going to play a quick clip. I hope the audio works. If you get feedback, please let me know. I'll put headphones in, but I'm going to play a quick clip from another episode in season 3 that I was also just assigned to help out with this. But this whole segment pretty much sums up the type of work that I do on Star Trek.
Are these values from a magnetic or a mass spectrometer?
Duh.
Which means magnetic.
I know what duh means.
Can we just irradiate your entire personality?
Calibrating for a cosmic background radiation.
I was just going to ask you to do that.
Duh.
Your relationship isn't very professional.
It's how we work.
I've been trying to raise the bar.
Tilly?
Yes, hi, Michael, I'm here. You also have Commander Stamets and Commander Reno. We're analyzing the radiation.
Listen, Dr. Addis is the only survivor. He described the ship being hit by a bright light, and the bodies of his family are showing high concentrations of beta particles.
Well, that could be any number of things.
He's also phasing uncontrollably.
Okay, now we're on to something. Beaming is the only way in or out of the seed vault, right?
I'm going to look for the nearest star.
You're thinking CME.
Yep.
What am I missing?
The ship may have been hit by a CME, a coronal mass ejection. Kind of like a star burp.
Burp in this instance would be a massive radioactive proton storm.
It should kill anyone instantly, but if Dr. Addis was in the process of beaming into the vault when the CME hit, the protons would have interfered with the ship's magnetic shielding and destabilized his body's polarization on a quantum level.
Right.
Bingo.
Oh, yep. CME, almost 6 weeks ago.
Now his body's in limbo. May I never say the same about myself.
Is there a way to bring him back in phase?
I think so. But I'm pretty sure he's not going to like it.
So that perfectly summarizes the type of stuff that I do on the show, because the reason that I brought up that example was, first of all, they said we need a space disaster, so come up with something. And I love coronal mass ejections because they're awesome and deadly. And then we have to come up with like the science of it, why that caused the transporter accident, what happened. But then we also have to come up with how they explain it in a way that makes us scientists happy, but also can be familiar to people who might not be scientifically technical background. And part of my job as well is to advise on how scientists would solve this problem, right? The scientists are being scientists in that moment, and what sort of clues would they need? How would they piece it together? How would they narrow it down? And so it really kind of ties all of those aspects of the job together to try to show how like we integrate science into the show and try to make it as accurate as possible. There's lots of different subtle facets to the job. And I managed to get CMEs into Star Trek, which made me really happy. So moving on to season 4 of Star Trek Discovery, we thankfully for this one, I was there like from day one of trying to come up with the plot of Star Trek Discovery season 4. And they had this idea for what we ended up calling the dark matter anomaly. But the brief that Michelle and the team wanted was essentially that there was an advanced species that lived just outside of our galaxy, what would be considered the border of the galaxy, because that's been a Star Trek thing that's happened before. They're highly technological advanced, and they are essentially using a sub-deep ocean dredge to try to find material that can help power their civilization. And we ended up calling it the dark matter anomaly because it had acquired a huge gravitational presence, the process that they were doing. And from like an environmental, of course, allegorical reflection on our own society, they had no idea that it has amassed so much gravity. This is 5 light years across, that it is actually destroying entire star systems because of its gravitational presence. And so we came up with that idea, and there were lots of little fun things to put in it. Essentially, it was working like a wormhole. And that was sort of the first part of the season, is where Stamets is trying to put the data together again, thinking how scientists would think, to try to figure out what this thing actually is. Is it artificial? They don't know an alien species is doing this. Is there any technology to it? Is it, what is it looking for? And so the first kind of half of that season is all narrowing down that whole process, to the extent that they had to math it. And this is where I get a call from the graphics department that says we need equations for a wormhole, because that's what he thinks it is initially. It looks like a primordial, I think we called it primordial wormhole, that's sort of popping in and out of space. And so I went through and I found, our good classic for people with this astrophysics background. You might be able to spot sort of general relativity equations in there. There's also some tachyon stuff on the left-hand side, and and space-time Minkowski stuff as well. There's a lot of math in there. Anyway, that's all my handwriting. They basically, I just wrote out all these equations and they just went whoop, whoop, and put it right into the show. So that was pretty cool. That was pretty fun. And there is, again, primordial wormholes are not a thing, but there's enough mathematics of wormholes that we can try to put some stuff together that Stamets would be staring intently at, trying to figure out what data they need. And they eventually figure out it's not a wormhole because it's not emitting tachyons, which again are theoretical, but they're not fictional. They're a tangible thing that scientists are trying to discover. Oh no. And then the other thing that I had to help with was that they wanted to do a sort of system diagram in fact, there wasn't really much of a brief for this. Essentially what it was that one of the characters was going to be captured and they were going to see a flaw in the system flow. I don't think they even used the term system flow. They were just like, they need to look at whatever they're looking at and they're going to see a flaw. And I was like, oh, that's like an engineering flow diagram. So I did a little sort of lunch lesson on engineering flow diagrams and sent them a bunch of briefs on it. And then you can kind of see in the bottom underneath the box highlight, there's a little red feedback loop that is feeding back into the system. And that's the flaw that they are gonna take advantage of. So even just pulling from engineering and helping with graphics on this was really, really fun. Thankfully, I didn't have to be artistic. I just had to teach them what to do. And the equations there are just, they're made up. They're in different languages, so it's fine. Don't look too closely at those. The whole point was just to have a flow diagram. And then the really fun thing with this season, in the back half, once they realize that there is a species that's doing this, they don't know that they're causing damage, they try to make contact with them. And I will say the episode is called Species 10C, and it's probably in my top 5 ever Star Trek episodes because it is so science-y how they try to figure out. If people liked Arrival, I can't recommend this episode enough because it's very, very similar in like, how do we communicate with a species that we have no way of communicating with? A lot of what I did for this was, you know, they had the team from METI on as consultants for this. So this is the team that's, it's an organization that is looking at Linko language. So using mathematics as a way to communicate with other species in solar stuff, different aliens, trying to communicate with aliens and using math. But one of the keys that I had to help with was, okay, yes, math and Linkos language, like that is possible. That is an interesting approach, but there are still some fundamental mathematics that you need to do. And for anyone who took abstract algebra, I apologize for bringing this back to you, but this is so you're telling me 1 + 1 = 2. That's how we're going to establish communication. But what is 1? What is plus? What is equals? What set are you working with? And so figuring out the best way and like how mathematically we would actually start that level of communication, we had to do. And the writers, I think, are still upset at me for giving them long-term migraines trying to learn abstract algebra. The other really, really fun thing I don't have a slide for was that we were going past the galactic barrier. Right. And this was this is pure Star Trek. This was original series. The galactic barrier causes like these psychic visions and it's like really bad for you. And it's a really dangerous thing. And so they wanted to pay homage to the Star Trek aspect of a galactic barrier. But then they call me and they're like, but is there science to the galactic barrier? And I'm like, well, no, not really. But like, let me think about it. And so I was thinking about like the heliopause, right? The idea that our solar system has this region where massive particles have velocity and they don't have quite enough velocity to escape the gravity of our solar system. And so they kind of come to a stop about 1 light year-ish. I don't know if it's 1 light year, maybe less than that. Anyway, don't quote me on that, but they come to a stop kind of at this, what we consider the edge of the galaxy, and the Voyager 1 and 2 spacecraft have passed through the heliopause and have detected this sort of higher zone of radiation. So I was like, what if the galaxy had something like that? What if there was a bunch of radiation particles that could escape their star systems, but couldn't escape the gravitational pull of our galaxy? And I literally was like, I think it's like the galactopause. And then a week later, I kid you not, a paper appeared on Archive about a galactopause theory, how we would be able to detect a region of high radiation that's surrounding galaxies. I was like, yes, it all comes together. So that was pretty cool. All right, I'm going to briefly go through some of the other shows that I worked on. Star Trek Strange New Worlds. If you have no association with Star Trek, no idea where to start, this is a great entry point. Strange New Worlds is fantastic. It's totally episodic, so every week is a different adventure of the week, and it's a great intro to Star Trek. I helped out with this one episode, so this is a young Lieutenant Uhura for the Star Trek fans out there. She is working as a linguist, and they come across a species that she is able to decode their language using music. and talking about how music is mathematical. And through the math of music, you can create a language because there are fundamental rules to frequencies, to harmonics, to all of these things that you can almost create an alphabet through. And I don't want to be too braggy about it, but apparently linguistics Reddit was very happy with the episode. So I was good with that. That made me happy. And then the big episode that I worked on was actually called Memento Mori, where they get into a battle with the Gorn. Sorry, spoilers. And they decide to hide in the atmosphere of a brown dwarf that is orbiting a black hole. So the black hole is slowly, like the outer layers of the brown dwarf is falling into the black hole. So there's your ticking clock for the episode and how they need to sort of figure out a way to get out of there. It's a very Hunt for Red October submarine style. They decide to use the gravitational field of the brown dwarf to position themselves above the Gorn ship and just drop a torpedo onto them. And then when they do need to escape, this was fun, but please don't scratch too much on the surface of this. They decided to use gravitational time dilation to slingshot themselves around the black hole, which would actually delay where it looked like they were. So by the time they were around, the Gorn would still think that they were falling towards the black hole. I was good with it. I was happy with how it turned out. So that was a really fun episode. For season 2 of Star Trek Picard, I was working on this one. I didn't get to do too much on this. Some of you may realize like there wasn't a ton of science in this season, just because of the nature of the storyline that they used. But I was given the brief for one episode where 7 of 9 wakes up and she doesn't have her Borg implants anymore. She's trying to figure out what happens. And they were like, what would be a good equation that someone would check to like just check that they remember how to do math, that they remember some physics or some math thing? And I was like, the best equation. So Euler's identity, e to the I pi plus 1 equals 0. That was the equation that she quickly jots on the mirror in lipstick to try to make sure she knows math and science. And I literally just had to take a video of me writing this over and over and over again so Jerry Ryan could study how someone would write this in the right order. And we don't think about that as scientists, right? But as actors, they were like, how do you write pi? Do you do the line above first? Do you do the lines after that? Like, how does that all work? And so that was what so that's what I helped with that one. That was exciting because I love Euler's identity. Who doesn't? And then Star Trek Lower Decks, for any fans out there of this show, I worked on season 2. I worked on it since season 2, but in season 2, the finale, the showrunners came to me and they just said, we want to make the ship look naked. How can we do that? So I was like, okay, well, there's like an outer hull plating and an inner hull plating, and we could have like some sort of radiation storm that they have to get through. And so they have to get rid of all the outer hull plating and then fly silent because the outer hull plating is magnetized. And so we went with that. And actually, there was a ton of science in that episode, a lot of techno babble, but it was pretty self-consistent. So I was happy with that one. And I'll come back to that in a little bit. And then Star Trek Prodigy is the new kids show. They just finished season 1. It's in partnership with Nickelodeon. It is for kids, but I think it's adorable. And the visuals are fantastic. And this is also a great entry point to Star Trek because it is designed for kids who have never seen an episode of Star Trek. So this is a really, really fun show to watch. And Admiral Janeway is back. They have hologram Janeway is their like trainer who is on the ship with them. But this was a very, very, very big deal for me because Voyager is my favorite show. It's my favorite one. I have a tattoo of Voyager and I dedicated my PhD dissertation to Captain Janeway for helping me get through graduate school. So working on that was particularly special. But the first job that I got on it was for episode 3, which for those of you who might have tried Prodigy, 1 and 2 are to get kids who are watching the other Star franchise to watch this franchise. So if it felt a little bit too much like the other franchise, watch episode 3, because then they're like, nope, psych, you're watching Star Trek, because they get trapped in the gravitational well of a binary white dwarf red giant system, and they need to get away before it goes supernova, a type 1a supernova. And they explain it. I got to write some dialogue for Captain Janeway, which is like a big deal for me. And it was really cool. And then they slingshot around and fly away right as it goes supernova. But one of my favorite episodes from Prodigy is actually called Time Amok. And they created a ion storm, good old Star Trek adventure where if you were close to the engine when they got hit by the tachyon storm, your time dilation was more severe, and then it went down the further you were away, but it was an oscillating sine wave, damped sine wave. And so the person who was the closest to the engine had the most positive time dilation, positive in the sense that their time went much faster than normal. The next person furthest away was Rock Talk. She was, her time was extremely slowed down relative to everyone else. And then opposite as you went from there. And then they all have to work together to fix the engine and across different time experiences. This is the first time I've ever seen a graph in a script. So credit to the writers. I just gave them the term damped sine wave, but they came up with that, and it is brilliant. This was a really, really fun one because in the back half of season 1, they were trying to escape, and they said Okona the guy who has this craft, pulls out like a cylinder of bright green fluid, and they made up some technobabble word for it. They put it in and the engine flares. And I'm like, you mean chlorine trifluoride? Like that is rocket fuel that glows green, and it is dangerous as heck. and so they were like, oh my God, yes. So we put chlorine trifluoride into there as well. Then the protostar itself, I'm not going to dwell too much on, but they came up with this idea when I first got onto the show. They were like, okay, so the engine's like a normal starship. It's got a warp core. It's got all the things we know and love, but it's an experimental ship because it has a new technology that is what we call the proto drive. And it's because there is a protostar on the ship. and when they engage the proto drive, they go even faster than the speed of light. So science that, please. It's like, oh, Lordy. Okay. So protostars, as far as we know, cannot be that small. But imagine you could get a bunch of gas and put it into a chamber and compress it right to the point that it's about to start fusion. You technically have a protostar. And then when you want to engage it, you can compress it even more with some gravitational field that will actually start a fusion process, which is going to give off a ton of energy, which can then supplement and basically create like a wormhole in addition to the warp bubble that you already have. Then when you're done using it, you relax that pressure and it goes back into like the stable gas form. I'm sure that's we're going to work with that. It fits their story. It fits what they wanted to do. And I'm pretty happy with it. I think the explanation kind of works. Some of the other fun things that we were able to do with this was actually establish Star Trek technology that's been around, but never been clearly stated how it actually works. So at one point, our good friend Murph here eats some photon grenades, and Rock Talk, who's sort of Murph's little caretaker, she comes running in and says, what happens if you eat photon grenades? And one would explode into a burst of gamma rays. And that had never been established, like what a photon grenade is. They just said it's bad. It's essentially a nuclear bomb because it is a huge explosion of electromagnetic radiation, but high energy electromagnetic radiation, photons, gamma rays. The other thing that we did was there was a holodeck emergency episode. So the holodeck, of course, is like a virtual VR world. And how does that work? It works through motion floor tracking and visual horizon manipulation. Sure, we've never said how the holodeck works before. That's how it does now. And then the last thing that was really fun was particularly transporters. It converts yourself into energy data, basically, and then that signal gets where you want to go and then converts you out of other existing matter back into who you are. So they'd never really said specifically that before. And then the other fun one that we did was they wanted to have sort of a big chase through warp. And they were like, well, can warp bubbles like merge? I was like, well, that's a good question. And I'm thinking about the mathematics of warp drive, which is a thing. And I drew this highly technical diagram that said, sure, they can merge. You get one warp bubble, another warp bubble, then nacelles that keep the warp bubble stable flare and try to maintain that stability before it eventually overcomes. And now they're sharing a warp bubble. Mathematically, it works. And this is my highly scientific drawing to show that reason I'm not in animation. And then Rok-Tahk in particular, this was really fun. So in that Time Amok episode, one of the big things is that she's a Brakar. So she's like this big, scary looking alien. And she's always been assigned like a security officer, or like a fighter. But when she's in that episode, Time Amok, and time is going really slow for her and she's by herself, she starts studying science and engineering to try to solve the problem and bring everyone back. And she finds that she really loves science, but she doesn't know what kind of scientist she wants to be. So in this episode, they're trying to, I think this is episode 11, they're trying to escape from a destructed space station. And she's been studying orbital dynamics. And so she runs out and she's trying to calculate what velocity and trajectory they need to go on so they can just float towards where the protostar ship is going to be by the time that they get there. All of these equations that I gave them, some units, some equations, fans did screenshot every single minute and check all of my math. That's fine. But we made sure that it was all correct. And then the other thing too was just telling them like, that is orbital dynamics. You know, originally they were like, she's just studying astronomy, but I'm like, well, really what she's doing here is studying orbits and velocities and all of that. And so she screws up the trajectory ever so slightly, just because the space station explodes right as they jump off of it. So it gives them a little extra boost. And then she's all disheartened and is like, maybe orbital dynamics isn't for me. But she keeps exploring science and keeps trying to figure out what science is most for her. And this character in particular, I not only have advised on like all of this technical stuff that I've given you and all the Star Trek technical stuff, but also trying to create a character that would be an inspiration for kids that they can look at and be like, oh, I might want to be a scientist too, and relate to Rok-Tahk in the same way I related to Dana Scully and Captain Janeway to try to become a scientist. The last thing that I have a big role on is managing all the star dates. No, I can't tell you my equation. Yes, there is an equation. Yes, it keeps me up at night. Yes, fans hate me because of it, but we do have a plan. It's just that fans have created a lot of their own star date calculators, and we don't want to upset anyone, but we are consistent and we made our own judgments. I went through all of the star dates that we've had in Star Trek, and we came up with an equation that we use on all the current shows, and it pretty much fits all the ones that came before, except for Strange New Worlds, because they follow the same rules that the original series did, which is just pick a number, and that's fine. And the in-canon, the in-universe explanation is that it's a combination of lots of different information. It's not just time, but also your position in the galaxy and how fast you're moving. That all gets condensed into one number. But anyway, I'm just wrapping up, but people ask kind of what's the coolest thing? Obviously working on Star Trek, but I think really seeing my name in credits in Star Trek font with Star Trek music behind it is a little bit emotional for me. It's really cool. It's a really special experience for me. And then I've been so honored because not only have I had this role behind the scenes, but the writers have started to create a Dr. Aaron multiverse within Star Trek. And it started with Lower Decks. In that episode I was telling you about in season 2, Kayshawn, who's the one looking terrified there, says, we should just warp past the debris. And they all yell at him. And the science officer's giving fisticuffs. And Shax, the big guy next to him, shouts, Dr. Aaron said we can't do that. So they made me canon in that moment. And then Prodigy said yes and took it one step further. because when all the kids get to Starfleet at the end of season 1, told you I was going to spoil it, they go around and meet all the different divisions and things that they're interested in, and they have Rok-Tahk go to the science division, and she realizes how many sciences there are out there, and she's been working her way through all of them, and she meets a science officer at Starfleet Academy called Dr. Aaron, who is voiced by me, based on me. And that was just, it was very touching. And I think the biggest reason that it was so special for me was because when I left academia, I really felt like I was cutting myself off from the opportunity to mentor kids and to inspire future generations. And so having that be a conduit through Rok-Tahk, but then to have it come full circle with me being the one that inspires her to study xenobiology was really, really special for me. So with all of that, I will end it here, and I have time for questions, but thank you all very much.
Thank you so much, Erin. Does anyone, I'll open up for anyone in the audience to ask questions, because we know that I will take over. So please take this opportunity while you have it, y'all. Go ahead, Mariette.
I'll just chip it off. Oh, I see there's another one, but I'll be quick. So, Erin, I love hearing about how you get, like, first of all, it was great to hear all of it. Thank you so much again for joining us today. But, you know, one of the things I wonder about is how do you, I could see you get a lot of joy in finding ways to get the science really in there. You know, is it also sometimes kind of frustrating, or are you just used to that by now? I know there's also a story. Yeah, and I know
that's great. It's a good question. I think, you know, one of the successes that I've had in this industry has been my positive yes and approach when they come to me with a problem, is that I don't want to tell them that it's not going to work. There was a lot of back and forth, I will say, in Discovery season 4. At one of the moments they were in that dark matter anomaly and they were going to ride the gravitational waves out. And they did. That's in there. And we talked about it. And I was like, well, gravitational waves are like quadrupolar. And it's like, that's not really how we do that. But we did make a visual that looked more, as they're in the ready room giving the explanation, we made a visual that looked like sound waves, more compression waves, which is a little more accurate to how gravitational waves would propagate. And it was so visually confusing to people that we ended up just going with good old waves that they're writing out. It is a little bit just personally mortifying, because that is what I did my PhD in. So my friends are, you know, texting me being like, are you kidding me? You know better than this. But it's like, we tried, and you got it. The main goal is to not pull people out of the story. And it did look weird with it being as close to accurate as possible, that people would be like, wait, what? I thought they said that they were waves. And so we went with what we know, so you don't lose that pacing. But yeah, that's a great question.
Love it. Thank you.
Yeah.
Tyler, do you want to call on folks? Because yes. I'm not sure what order
Erin.
Yeah, hi. Thanks, Erin. Really enjoyed this. I'm sorry if I got in a little late, so if I missed this, but I'd really be interesting to hear, like, from a professional development standpoint, what, like, your process getting into this industry has been like, and I don't know, yeah, just how you've sort of worked through that and what you've done.
Yeah, I touched on it a little bit, so I'll go through it briefly, but I think it's good to kind of reiterate the process I went through. For me, it was very much about really loving science communication and finding ways to integrate fictional storytelling with that science communication. And physically being in LA helped as well. But I think the big thing was knowing how to tell stories, knowing how television and movies are made, but using those stories to teach science is what kind of got me on the radar for the entertainment industry. And then again, has helped me be successful, because I understand, like, stories and characters come first, and then the science comes after that. And if we can make it all work, at the end of the day, my main job is to make sure we don't say anything wrong. That's like the only thing that I main brief. Everything else on top of that is just sprinkles. So yeah, but thank you. All right, I think Julia is next.
Hi there. Thanks so much for your discussion. Really fascinating. I'm a Star Trek fan, so this is fun. I hope you don't mind. I have two questions. My first one is, what's the most difficult part of the job? That's the short question, and I guess you can think about it while I ask the long question. Are there others like you in this industry? How common is your type of position that you hold? Is it very common, or is it really unique because of like the breadth of Star Trek's subject matter? That's what I'd love to know.
No, that's great. I'll start with the last one. I think there's not a lot of us out here working in this industry just because it's not the type of job that they advertise for necessarily. It's all about the networking. And so for people who are interested in getting into it, it's about trying to meet other writers, putting yourself out there. There are people may have heard of things like the Science and Entertainment Exchange, which is a way to connect scientists with writers. There's pluses and minuses to that organization. I think what they do is great. And I upfront apologize to anyone here who's involved in it, because I don't want to sound like I'm being negative about it. I think the tough thing is that because it's through the National Science Foundation, you don't get paid for that, which I think is pretty unfair, especially on major union films, where it's like, if you're going to advise on an MCU film, you should be paid for that. So that's kind of the only gripe I have with that process. But that being said, it is a great way to get experience. The other one that I would advise is, if you go, I'll try to grab the website for a second, or if Tyler can, if you go to coverfly.com, and then up at the top, they have like a Coverfly X, which is a script exchange program that it's mostly for writers to read each other's drafts, but there's nothing to preclude you as a scientist for offering to read other people's scripts and give them notes. And I think even though, yes, that's unpaid, it's all volunteer, writers trade tokens. So it's like you get a token if you give notes, and then you can sort of pay someone else to read yours. But if you want to get experience reading science, you can like filter by science fiction and give notes just on the science. That is a great way to get in on that. And then also they'll know who you are. So, Coverfly is a very professional website, and I've had a lot of people, meet future writers. People have gotten jobs off of that. So that's another great one. Great. Thank you, Tyler. I saw it pop into the chat, so I appreciate it. And then the hardest thing about my job, for me, I'm grateful that I like reading, because I have about 280 pages of scripts right now that are sitting in my inbox that I need to read by Monday and give notes on. So when it rains, it pours for the television industry, is that they kind of slow start, and then as soon as they hit running, it is scripts, revisions, outlines, revisions, like everything's just coming in super fast. And so trying to manage that time can be very, very difficult for sure. Yeah, thank you.
Hi, I'm next. I'm Davy. So first off, I wanted to say I'm actually born and raised in Colorado, and I'm currently doing my PhD here. So I may have actually seen you at that exhibit at the Denver Museum of Nature and Science, which is awesome. So awesome. Fantastic. So I guess I also had two questions for you. So I was wondering if you had gotten any formal teaching experience while you were in grad school or during your postdoc, or when you moved here to Colorado and started doing those presentations for the public. Was that new and different from what you had done during your graduate work or postdoc?
Yeah, thanks. I mean, I had probably as much teaching experience as most of us in hard research academia get, which is a professor says, I've been assigned Astronomy 101 and I don't want to teach it, so you get to go teach it. And I still remember that first day of having no guidance and being like, all right, here's the syllabus, here's the textbook, just teach this. So it was trial and error. But yeah, I did teach astronomy classes. I taught labs as a graduate student. And then I taught intro classes when I was a postdoc at Cardiff. And then when I came out to Colorado and I was working at the Science Museum, I also did adjunct teach at the community college, teaching astronomy and physics. And I really loved teaching intro classes. And that was actually one of the places where I learned how effective science fiction can be to engaging students, because we were learning about exoplanets. And I mentioned that, I think it was Kepler 21b or 12b has two suns, and or two stars. And I said offhand, I was like, yeah, like Tatooine. And then the kids were like, wait, what? Like, well, like, could it, would it be a desert planet? Like, are there people there? Are there wampas there? And they were asking, even though it was like a deviation from what we were trying to learn, they were asking questions you want a science class to ask, right? They were critically thinking. They were trying to understand, like, what would the sky look like? Would it look like that? Would the sunset look like that? How bright would it be? And so all of these things that you want your science class, especially an intro class where most of them just are taking it for the credit, to start getting engaged. So that's when I started incorporating a lot more science fiction references into just my traditional teaching classes. Yeah, thank you.
That's awesome. I had one more question, if that's okay. I don't want to cut anybody else off. Okay. And so in your current position, I know you have the physics background, but do you ever encounter like a biology question that you then have to like ask for other help outside of your field? Or how do you go about researching science that isn't necessarily something you're familiar with?
That's great. I do think that research set me up very well for this and teaching intro classes, because I have to be comfortable just saying like, I don't know, let me go look it up. And then there is a biologist who is sort of on deck. He's Professor Mohammed Noor at Duke University. He was brought on with me when we did the burn, but he's like the dean of arts and science. Like, he has a really big job. So this isn't a job for him, but he's NDA'd. And that's always the hardest thing, is that you have to, the studio doesn't want me just calling people, because then that starts to give away secrets. But I am able to run stuff past Professor Noor for especially like genetics and evolution and stuff like that. And then, it's really just that it's really the entry level and museum experience that I got of just being able to look things up, knowing what sources are reliable, and then having enough of a science background, even if it's biology, chemistry, medicine, to just filter the need to know, and kind of send them the resources and then just check how it comes across in the dialogue. Yeah. And
Thank
then
you.
I did see one in the chat, if I can answer that popped in from Shiva. I think it was how to manage low pay after exiting academia and moving into science communication. How to stay motivated. It's so my friends give me a really hard time because I left academia because it was too unstable, and now I work in television, which is possibly less stable, if that was even possible. But I think the thing is it's all about, I'm not being able to live is hard. And when I was teaching at community college and working at the Science Museum, I was also working the morning shift at Starbucks from 4:30 to 10:30, and because I couldn't pay my bills and I wasn't getting insurance from that, and that sucked, and that was really, really tough. That was where you have that hard conversation with yourself and you try to figure out what you want to do. And I ended up moving into aerospace engineering, which did pay well, but but then I missed the teaching, and that's why I started going to conventions just to scratch that itch for me. And then just doing that and putting in that investment in a unique way, I could still pay my bills. And I was burning myself out. So I don't recommend it as a career path, because I didn't have a weekend free for probably 6 months out of the year. But I don't think I ever made a profit, because any money I made from my job paid my bills, and then all the extra money went to going to these conventions and giving these talks. But it was something I loved doing. So you have to find that balance, which is really hard to do. Julia, I think you had a question next.
Okay, so you mentioned how Scully from the X-Files was a big inspiration for you. And I know I've heard of the Scully effect, how many women and girls ended up going into sciences after they saw this role model character. And I guess that launches into my question of what do you think of as your opinion on the role of science fiction in very real scientific progress and discovery? And right now, science is under attack from a lot of angles. Does this ever come into play in the writer's room, or as you're thinking about how to tackle certain ideas? I also know that there's a big lack of diversity in a lot of hard sciences. Does that ever come into play as an image you try to counteract in your writing?
Yeah, absolutely. No, I really appreciate all of those. I think, well, Well, first of all, like I am a direct product of the Scully effect, because I watched the X-Files and I went, she's cool and she's a scientist, so I want to be a scientist too. And I actually, on YouTube, I think there's a recording of it. I did get to do a panel with Gina Davis and Mayim Bialik on the Scully effect for AT&T. It was an AT&T event. I forget what it was called, but you can check those out. And yes, the short answer to your question, yes, it absolutely plays an effect on how we write our characters, how we consider how they appear as scientists. That, like I said, is part of my job to demonstrate what life is like as a scientist, whether you are in a galaxy and exploring stars or whether you're at home. But I do think just in general, what's great about incorporating science into science fiction is that it does make it seem more accessible, that it at least humanizes scientists. And sometimes we forget that there are lots of people out there who never see or know a scientist. It might just be like their family doctor is the closest thing to a scientist that they have in their life. And so being able to see them on television is really important. And then being able to show a diverse, representation of what that is and what that can look like is also incredibly important. And I think Star Trek it's a legacy I'm really proud to be part of, because they have so many firsts of putting, women of color, of putting, different backgrounds in different positions that had not normally been seen on television. And especially having characters like Benjamin Sisko, be the captain on Deep Space Nine as a Black man, and then having Captain Janeway be a woman. And then, of course, now we're in the world where, Star Trek has broken boundaries, and having LGBTQ representation on Star Trek Discovery is, instead of having aliens as allegories for trans and non-binary, that we have actual human characters who are trans and who are non-binary. And I just think that that's really exciting and important. Yeah, Deep Space Nine. It's really good. I think that took us pretty much up.
Yeah. Thanks everyone for asking questions. It made it a really easy mentor chat for me. Luckily, y'all's questions were the same as mine, so we don't have to hold Erin any longer, because I will.
It's all good.
So thank you all for attending this month's mentor chat. I hope with this one that you've all got a sense for how science communication and storytelling is, I flipped that, whatever. How you can use your storytelling in science communication, and that there are so many different avenues for you guys to go in, with your science backgrounds. Our 2023 Mentor Chat series is all booked up. You've already received the spring schedule, but keep an eye out for the rest of the year's schedule. And thanks to everyone who sent in suggestions. If any of you have any more guests you'd like to chat with, send them my way, because we're going to keep the series going for as long as the SciCommers exist. And Erin mentioned taking acting classes, and just for anyone interested, we will have Laura Lindenfield from the Alan Alda Center to give a mentor chat about using improv to communicate science in June. So make sure you guys register for that one. And with that, I think the mentor chat is over. Thank you all.
Thank you all. Live long and prosper. Have a good one. Thank you. Bye-bye.